All right, our next hydrochlorofluorocarbon is going to be 134A. Now you'll notice in this PowerPoint, in this training, MACS refers to different types of refrigerants as their actual hydrochlorofluorocarbon and abbreviation of HCFC or CFC or whatever it is, depending on the freon. Um, in the industry, in the field, we have a tendency to just simply use the word R, refrigerant. So refrigerant 134A, R134A, or R22 or R12. So R12 is the one we covered in the last video, the toxic one, bad for the atmosphere, blah, 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 blah. Pretty well got rid of it in, 1992, I believe sounds like the right year. There's a slide coming up. I'll tell us the exact year, but 1992 is pretty darn close. It was replaced with R134A for automotive and trucks and tractors and stuff like that, HVAC systems. R134A, not as toxic, but still has the greenhouse gas effect. And that's another thing you're going to need to know. In fact, you might even keep it in mind for the test. A lot of the time, there's a question in there talking about, it's usually worded something along the lines of a refrigerant or multiple types of refrigerant of some kind will cause what to the ozone or to the atmosphere, or what are the effects on the ecosystem, something along those lines. And your optional answers are greenhouse effect and or raises the amount of temperature. Oh, I can't even think how it's worded. Sorry, trapping. Yeah, contributes to trapping heat. That's the wording they like to use. That's what they use for greenhouse gases. Contributes to trapping heat. So if you run into that question, that's going to be your answer. Other options will be something like depletes the ozone. Some of your older refrigerants may, but none of your new stuff does, so that's not a very good answer. Go for the one that says either greenhouse gas or contributes to trapping heat. So then your HFO 1234YF. Okay, so this is the brand new system. This is only on light duty. This is only the brand new brand new off the rack vehicles. They have to be retrofitted with this system, otherwise you can't use it. Not very many conversions being done, anything like that, because it has to be rated as a flammable. The vehicle has to be rated to be able to operate on a flammable substance, which once again we'll get to later, because 1234 YF technically is flammable under the right conditions. So, all right, CFC 22 or R22, that's your reefer systems, trailer systems. They usually have a question or two in there about the reefer systems as well. R1234YF, you're not going to run into much of it, but there will be questions on this test about it. And then the R22 as well. Just know R22 is going to be your cargo container systems, transfer systems. Your 1234 YF is going to be your newer systems, brand new, only used on new vehicles. Let's see, I believe it's the 1234 YF is flammable, and then the 154, I believe, is the other one that's flammable. That's something else that might pop up on this test. Like I said, we're going to cover some of this stuff a little bit later in slides. You're not going to see much of it in the field, but you need to know it for the test. All right, so ozone depletion. So this is where we're getting back into what I was talking about earlier. Depletion of the ozone layer has occurred at a rate of around 4% per decade since the mid-1970s and is beyond the scope of this textbook. A simple explanation requires understanding a little about ozone. Ozone in the upper atmosphere filters out some of the harmful sunlight directed towards Earth. Chemically, ozone, or O3, is a triatomic oxygen. That is 3 oxygen atoms to form an O3 molecule. Okay, so they want us to understand this for this test. You got to know what ozone is. You got to know what it's made out of. Um, and even if you don't believe in the greenhouse effect, you don't believe in whatever it is, it doesn't really matter what your political view is. You're taking a EPA approved test that is going to say, doesn't matter what your political affiliation is, greenhouse gas exists for this test. Period. Um, you just have to get in that mindset, otherwise you're going to miss 2 or 3 on this test. So keep that in mind. All right, so future refrigerants. This gets into kind of that 1, 2, 3, 4 YF. It's coming. It's coming faster than anything else is. But another one is CO2. A lot of people are starting to use, or a lot of people. Some foreign countries are starting to put CO2 into some systems. Basically, CO2 can be vented to atmosphere. Ain't gonna hurt a dang thing. In America, we use CO2, but not to actually run the system. A lot of the time, we use CO2 to test the system for leaks. So if we know we have a leak, instead of wasting a bunch of money on Freon and charging the system up with Freon, instead we fill it up with CO2 and check for CO2 leaks. Sometimes it's a little bit easier. Sometimes it's necessary. Sometimes it's not. I mean, it just kind of comes down to you and your personal opinion. But you can use CO2 to actually run a system. Whether or not it'll make it to America, we'll see. All right, types of refrigerant oils. So, hydrocarbon, fluorocarbons, they require the use of very specific oil. Your 134A is going to be PAG oil, PAG oil. That's your polyalkyl glycol oil. Your other one, your R12, so your older systems, somebody brings in something antique into your shop, something like that, you might run into it. And when I say antique, I mean as late as 1990s. So, I mean, you can still see this stuff. R12, that's going to be more of an ester oil. And you have to know the difference. You can't put the wrong oil in. It'll freeze up the system and cause it not to run right. So make sure you know what you're working on. Make sure you get the right oil in the system. All right, contaminations. This is right now. It's just going to get into contamination a little bit later. We're going to get into cross contamination as well. That it's a little bit nasty. So R134A systems look similar to R12 systems. However, refrigerant should never be mixed in the system. To emphasize this fact, it has been made illegal. Guidelines issued by the Environmental Protection Agency specify that all refrigerants must be approved under the Significant New Alternatives Policy, or SNAP. Only R134A meets current SNAP guidelines for mobile refrigerants, but a number of other mobile refrigerants are under research. So the ones under research are the 1, 2, 3, 4 YF, the CO2, stuff like that. But currently, 134A is the only one that meets SNAP guidelines. You can't mix, period. Cross-contamination, it's going to create high pressures. It's not going to operate properly anyway. However, if you ever do get a mix by accident or whatever it may be, the issue you're going to run into is the EPA has actually made it a regulation that if you do so, you can be fined, and you do not want to be hit by the EPA. I mean, what's the chance they're going to find out? But all the same, if they did, you're in trouble. Same with venting to the atmosphere. Never, ever, ever open up an AC system up to atmosphere on purpose. If you do that, holy cow, they'll hit you good. In fact, you know what? Let me go to the next slide here. Yep. Current fine for releasing a refrigerant into the atmosphere, $32,000, $500 per event. That's a lot of money. Never, ever, ever open a system up to atmosphere. Never cross-contaminate on purpose. Don't mix them on purpose. Um, like I said, probably never going to find out, but even then, it's not worth the risk. If they catch you once, wrong person sees you do it one time or catches you on video, cameras are all the rage anymore. They just don't like you for some reason. They can turn you in, you're 32 grand in the hole. Um, so just watch it. Don't do it. Be smart. Don't open it up to atmosphere. Um, don't cross contaminate or cross mix, accidental or on purpose. Just watch it. All right, so temperature and pressure relationship on refrigerant. It's a little bit different on refrigerant than it is on water, but it is the exact same thing. The basically the more pressure you put on a refrigerant, the uh, higher the boiling point becomes. So therefore, you can put the system under, let's say, a typical operating AC high side pressure of 250 psi. That's a lot of pressure, right? So it's that refrigerant has to get extremely hot before it's ever going to be able to boil, which is a good thing because you don't want refrigerant inside the lines boiling um, until you tell them to, until you put them through a state of change through the condenser. And even then, it's not necessarily boiling, it's just state changing um, through the absorption and or release of heat. So you don't want it to boil, so you got a very high pressure. And then on the opposite end, you want a very, very low pressure when you're on the low pressure side and you're cooling things off. So refrigerant makes a nice little, both R12 and R134A, they both did a very sufficient job at this. The difference, once again, R134A just doesn't have the toxins that R12 did. All right. Okay, so refrigerant containers for R12 and R134A are color coded. Same with the 1234YF if you ever are working on automotive, smaller, light duty, new vehicle. You want to go home, work on your own stuff. It is also color coded. The 134A, most common, light blue container. You're going to see them. In fact, we got a picture in these coming up here in a little bit, but they're out in your shop right now. They're all over the place. R134A is very, very common, light blue. The 1234YA is a white container, and it has a red stripe on it, where the R12 containers are just white. So R12, the old containers, plain white. Honestly, you really probably aren't going to see those very often. However, after this class, you will be certified to buy R12. So if you want to, you can work on R12 systems. If you don't pass the test in this class, you are not allowed to even touch an R12 system, period, even on your own stuff. R134A, you are. Uh, So, with that being said, that's another thing. The containers, any type of transfer container, anything like that, it will be marked. It's going to be marked, excuse me, sorry. It's going to be marked, stamped 4BA. Has to be stamped, otherwise, you can't use it. Refrigerant identifier, so you're walking up to a system now. Obviously, the most common way to identify a system is the EPA or the SNAP and EPA have regulated that every single AC system, different refrigerant has to have its own style of fitting. So you can't even hook up to the system unless you're working on the right type of refrigerant. So R12 has a certain type of fitting, R134 has a certain type of fitting, so on and so forth. Now, with that being said, though, it doesn't mean that the mechanic before you knew what he was doing, was certified in what he was doing, or anything along those matters. So you do got to kind of watch it a little bit. The easiest